is a nutrient sink within the system because these organisms are living typically up to 50 years. So they're storing this amount of carbon, nitrogen, phosphorus for 50 years. And the storage is the biomass per meter squared times the percent nutrient composition of their tissue. However, it's hard to compare these two because this is a rate and this is a mass. So how do you get to comparing those two? So in order to turn my storage into an actual rate, I took estimates of growth rates of these species. So if you know how much they're growing over time, then you can say this is how many nutrients they're storing over time. So I got data for these species from this manuscript here by Haag and Reipel. Currently, I just finished getting growth rate estimates for organisms from my own system, so more to come later. But anyway, so this calculates the aerial storage rate, so it's the aerial storage times the growth rate. So just moving on to aerial excretion. So if I compare my results here with the mussels to previous studies, mussels have the highest end aerial excretion rate of all, except for those invasive snails I mentioned to you before from Wyoming. So this is the second highest end aerial excretion rates ever reported in the literature. And then for phosphorus aerial excretion, I found the highest phosphorus aerial excretion by these organisms. So 10 to 35 micromoles of phosphorus per meter squared per hour. That's a lot of phosphorus over time, and when you think about it. And across these sites, these organisms are storing up to 93 grams of nitrogen per meter squared and 34 grams of phosphorus per meter squared. So they're this kind of nutrient sink within the system. And additionally, you also have to realize, so here, the red is the shell. The shell you can think of as a very long-term store as a nutrient sink because even after these organisms die, the shell stays around in the system for up to 10 years, if not more, based on our decomposition rates of shells. And then when we look at that storage rate versus the excretion rate, so excretion minus storage rate, you can think of this as source versus sink. So when you compare those, it seems as though mussels are a net source of nitrogen, so they're remineralizing more nitrogen than they're storing. And then for phosphorus, it's still unclear because I had some sample sites that were negative, but on average they were a net source of phosphorus. But